Hello everyone, my name is Gautam and these are the lectures from Nano IIT and NEET Academy. So we'll be discussing a few questions from this year's, like JEE Advanced 2025, from paper 1, paper 2. We picked some problems to discuss with you. Okay, let's see. First, let me tell you this. Actually, if you have seen the last 3-4 years papers, this is the easiest paper. Okay, so actually we have tried hard to pick some questions. Okay, so let's see what those questions are. There's almost one question from every chapter. Okay, so combined paper 1 and paper 2 combined, there's almost 1 to 2 questions from every chapter. And then I'll tell you this again. This is the easiest paper in the last 4 years. Okay, so 2022 being the toughest, and 2025 is the easiest paper in the last 4-5 years. Okay, let's see why are we considering this as the easy paper. Let's see the questions and let's see the logic in the questions. Okay, so what is the core point in the question? What is the core concept that is tested by the questionnaire? Okay. Now let's look at this. R denotes the set of all real numbers. Let ai, bi are all real coefficients in the given equations f of x and b of x, f of x and g of x. Now, look at this point. If f of x, if f of x is not equal to g of x for every x belongs to R, f of x not equal to g of x. Okay, let's break down this statement. Does this mean f of x minus g of x is not equal to 0 for all x belongs to R? Which means there is no value of x for which this equation is 0. Which means there are no real roots for this equation. F of x minus g of x has no real roots. Okay, so you need to understand that statement first, and then find the coefficient of x cube in h of x. We'll deal with that later. That is a simple thing, right? F of x plus 1 minus g of x plus 2. Just replace x with x plus 1 in this and x with x plus 2 in this, you'll get that. You'll find the coefficient of x cube directly. So let's look at this. For this equation to not have any real roots, what is the condition? Let's subtract f of x and g of x. Now, x power 4 cancel, and then we have b3 minus a3 minus b3 of x cube. a3 minus b3 of x cube, a2 minus b2 of x square, plus 10 minus 3, 7x, plus a1 minus b1. Okay, is equal to 0, has no real roots. Okay, so what should go on in your mind when this statement has, first when you crack this statement, has no real roots. This is a cubic equation. A cubic equation has at least one real root, or for that matter any quadratic equation, any real polynomial equation has even number of, just pause the video and think about it, has even number of imaginary roots. Yes, so in this cubic equation, even though the maximum number of imaginary roots is 2, there should be at least one real root. Yes or no? Okay, for this cubic equation there is at least one real root, but according to the statement this equation has no real roots, which means this is not a cubic equation. This is not a cubic. Means a3 minus b3 is equal to 0. Done. a3 is equals to b3. Okay, so this is the condition from the statement. Now f of x plus 1 minus g of x plus 2, all we need the coefficient of x cube. Coming to this, what is the coefficient of x cube in f of x plus 1? F of x plus 1. Okay, there's one thing here, and constant x terms and x square, you will not get x cube. a3 of x plus 1 whole cube plus x plus 1 whole power 4, and from g of x, this is from f of x plus 1, and from g of x plus 2 we have b3 of x plus 2 whole cube plus x plus 2 whole power 4. Okay, so you'll get the coefficient from this. So this is the core point in this. This is the core point in this question. Okay, a cubic equation. For this, let's not say this is a cubic equation. It's a polynomial equation. It doesn't have any real roots, which means this is not a cubic equation. Which means coefficient of x cube should be 0. Yes. Next. Now, let R denote the set of all real numbers. Define the function f from R to R. Domain is all real numbers. Codomain is all real numbers. By f of x equals to, this is the function given. Then which of the following statements is true? So, in the question we have, we are asked about the differentiability of the function. We are asked about the monotonicity of the function, whether it is increasing or decreasing, or is increasing or decreasing possible in a certain interval. These are all the options given. Yes, and also discussion about minima, local minima or local maxima of a function. Now coming to this, let's talk about the differentiability. Is this function differentiable or not? Okay. Now, can you directly differentiate this function and tell me whether this is differentiable or not? No. Okay. Look at this. I'm going to use the concept of LHD and RHD. Let's split it later from to LHD and RHD. First, limit h tends to 0. Already we have f of 0 equals to 2. We are going to use the function value. F of a plus h minus f of a by h. First principle. So if you use that, limit h tends to 0, f of a plus h. Obviously, at x equal to 0, we are checking the differentiability. So take a 0, then we have f of h 2 minus 2h square minus h square into sine 1 by h minus f of 0, which is 2 by h. So 2 and 2 cancel, and then what is left out? See, limit h tends to 0, minus 2h square minus h square into sine 1 by h. So if you take minus h common, okay, minus h if you take common, we have 2h plus h into sine 1 by h by h. Okay, so limit h tends to 0, this is 0, 0 into a finite value, h into sine 1 by h is also 0. So finally you are getting 0. Okay, so this is a finite number. It doesn't matter whether it's LHD or RHD or LHD, still the value is going to be 0, right? LHD is equal to RHD equal to finite, so the function is differentiable at x equals to 0. Now let's look at this. X equal to 0 is a point of local minima of f. Okay, so how do you check local minima and maxima? The sign change from positive to negative, it is local maxima, and the sign changes from negative to positive for f dash x, then the function will have local minima at that point. Now look at this. Is this function positive or negative? This is f dash x, right? This entire thing is f dash x. This is what we have done. Now is f dash x positive or negative? Is LHD, RHD. Okay, limit value is 0. Fine. Now tell me the f dash x value, left hand part, f dash of 0 plus f dash of 0 minus. What are these values? Positive or negative? F dash of 0 plus, see there is a negative sign outside this. There is a negative sign outside the brackets. So if h is negative, negative of negative positive. If h is positive, negative of positive negative. So h positive, if h is positive, which means the function is, so f dash x is negative. So RHD negative, LHD positive. Sign changes from negative to positive, positive to negative. So local maxima. Okay, the option is given as local minima. So f is not differentiable. First option wrong, last option wrong. If the function has local maxima, what does it mean? The function has local maxima. This is 0, which means, so after 0 the function is decreasing, right? Which means there exists some number delta such that f is decreasing in the same in some interval 0 comma delta. Is that point clear? Because the function has local maxima at 0, obviously there will exist some number where the function is decreasing. So option B, this is the correct option. Okay. Next. So this is a bit lengthy question in the entire paper, if you ask me, because here you have to find the composite function f of g of x and g of f of x both. Okay, that is why I am considering this as a lengthy problem. That's it. Okay, now let's look at this. So we asked about both g and f. So first, initially we need to find whether the functions f of x and g of x both are 1, 1 or onto or not. So let's discuss for one function. Okay, now you are clever enough to do the remaining things. Let's discuss about f of x or g of x. You choose one thing, f of x. Okay, f of n, f of x, n plus 1 by 2. N is odd. Okay, if you look at the domain of the function f, all natural numbers, so you can't take negative odd and negative even numbers, positive odd and positive even numbers. Next, for the function g, the domain is integers, you can take anything. Now n plus 1 by 2, n is odd, and then 4 minus n by 2, n is even. Now it's a very simple question. Now just keep on putting the odd numbers here. Tell me the range, that's it. You don't have to do anything. So first, what is the first possible positive odd number? 1, right? 1 plus 1 by 2. 1. Next 3, 2. Next 5, 3. You're getting all these things. And then second branch, n even. So what is the first possible even number you're putting? n2, which means 4 minus 2, 2 by 2. 1. Next 4, 0. Next 6, minus 1, minus 2. So this is the range of the function. This is the range of the function. If you look at 1 here, so f of n value is 1. If I ask you f of n is 1, find the value of n. What are the possible values of n? When n is 1, you're getting f of n as 1. Even when n is 2, also you're getting f of n as 1, which means this is not a 1, 1 function. Is this an onto function? Look at this. Observe the range of the function. Are there all negative integers? Yes. Is there 0? Yes. Are there all positive integers? Yes. So if you look at the codomain of this function f, it is integers, and we got all the integers in the range of f, which means this is an onto function. Range is equals to codomain, so this is an onto function, and for two different values of n, you're getting the same function value, which means this is not a 1, 1 function. Not a 1, 1 function, but an onto function. That is about f. So similarly, you can do for g as well. Now, let's find a composite function out of these two, g of f or f of g, whatever it is. Now look at this, g of f of n. What is g of f of n? This is g of n, right? When I say g of f of n, just replace f of n with f of n. Wherever there is n, just put f of n there. Minus 2 into f of n. This is when f of n is greater than or equal to 0. And this is when f of n is negative. Is that part clear? This is g of f of n. G of f of n, just replace n with f of n. Okay. Now, f of n is positive. Where is f of n positive? Look at this. Where is f of n positive here? N plus 1 by 2 and 4 minus n by 2. The first branch, f of n has all positive numbers. In the second branch, there's two values for which f of n is positive. Remember that 1 and 0, you got two numbers where f of n is positive. Now, f of n greater than or equal to 0, put that. 3 plus 2 into, when do you take f of n as n plus 1 by 2? And when do you take f of n as 4 minus n by 2? Okay, this is when f of n greater than or equal to 0, n is odd. And here, you see, Okay. Is that point clear? Let's move on to the next question. Let the set of all relations R on the set A, B, C, D, E, F such that R is reflexive and symmetric and R contains exactly 10 elements be denoted by S. Okay. So, and this is the simplest question in the paper. This is the simplest question in the paper involving a bit of P and C, a bit of selection. That's it. Okay. Now there are 6 elements. So for a relation to be reflexive, all the 6 sets should be there. All the 6 order pairs should be there. A, B, B, C, D, C, C, D, D, E, E, F, F. Okay. Those 6 you have to take. There is no other way. There is no other option. Now for it to be symmetric, see, 6 elements. Okay. All 6. A, B, B, so on up to F, F. All 6 you need to take. Those are 6 elements. Along with that, for a function to be symmetric also, and the question is about having 10 elements in the set, having 10 elements in the relation set. So we need extra 4 elements. Yes. These extra 4 elements should make this relation symmetric now. So what is the symmetric relation? How should the order pairs be? If there is A comma B, there should be B comma A as well. Yes or no? If there is B comma C, there should be C comma B as well. So for extra 4 elements, you need 2 different pairs of 2 numbers. Yes or no? You need 2 different pairs of 2 numbers like A comma B and C comma D, and it is understood that if there is A comma B, there will be B comma A. If there is C comma D, there will be D comma C. Is that point clear? Okay. Now you need 2 sets of 2 pairs. Yes. Now for those extra 4 elements, what I am doing is, first we'll select the combinations. Total number of combinations of 2 objects. Tell me this. Combinations of 2 elements. How many combinations of 2 elements will be there? There are 6 C2 combinations of 2 elements. So which is 15. Now out of these 15, you need 2 order pairs. Is that point clear? There are 15 combinations of 2 elements, and out of these 15, you need only 2. Yes or no? Because in this 15, we are not getting A, B and B, right? Getting only one combination. Combination means there is no point in arrangement. Yes? So out of these 15, you need 2. The remaining 2 will be reverse of these order pairs, right? If you are selecting A, B, you just put BA. If you are selecting CD, just put DC. That's it. Okay? Is this point clear? Is the selection clear? Yes. Next. Let us give a set of all 7-digit numbers that can be formed using the digits 0, 1 and 2. For example, this is in S, but this is not in S because this is not a 7-digit number. That number is starting with 0. Yes. Then the number of elements X in S such that at least one of the digits 0 and 1 appears exactly twice in X. Okay. See, there's 2 points here. At least one of the digits 0 and 1, and they should appear exactly twice in X. Okay. So how do you convert this statement exactly one of the zeros and 1? At least one of the sets A and B. At least one of the sets A and B, A union B. At least one of the sets A, B, C, A union B union C. That is what we need to find. So let's say number containing exactly 2 zeros. Let's say this is set A. Exactly 2 ones, set B. So we need to find N of A union B. Yes or no? Means N of A plus N of B minus N of A intersection B. This is all you need. So now numbers containing exactly 2 zeros. Set A I am doing exactly 2 zeros. Okay. All 7-digit numbers that can be formed. 7 digits. Number of elements such that at least, okay, sorry. This is 7-digit number. You are using 2 zeros. Where can you put these 2 zeros? How many places are available for these 2 zeros? There are only 6 places available because first place cannot be filled with 0. Yes or no? So out of these 6 places, you can select any 2 places for these 2 zeros. Now select 2 places from 6, 6C2, and then the remaining places can be selected in how many ways, or can be chosen in how many ways? Yes, remaining digits. So if you take out 2, how many places are left? There are 5 places left, and each place can be selected in how many ways? The number in each place can be selected in how many ways? 2 ways, because there is only 1 and 2 left. You can't use 0 again because there are exactly 2 zeros in the number. So now again each place, okay, 2, 2, 2, 2, 2, 2, 1 or 2. Now exactly 2 zeros. We are done with exactly 2 zeros. Now exactly 2 ones. Now how many places are available for placing 2 ones? All the 7 places are available. So 7C2, and then the remaining 5 places you can fill with 0 or 2, right? So again 2 power 5. Now n of A intersection B, this can get a little tricky, that's it, a little tricky, because this is a combination of zeros and ones. There are 2 zeros and 2 ones. Okay. Now how do you do that? There's 2 restrictions here. So you just fix one restriction and solve for the next restriction, the second restriction. Okay. Now numbers starting with 0, we'll do one thing, or okay, first place 0, first place not 0. This should be done. Okay, so the whole problem is with 0, right? You just so first place if it is 0 and first place if it is not 0. Okay, now the first place is not 0, select 2 places for 2 ones and select 2 places for 2 zeros. So how many ways you can select 2 places for zeros? 6C2. Now once you select places for zeros, how many places are left for ones? There is only 5 places left. Out of those 5 you can select 2 places for 2 ones, and then the remaining 3 places, the remaining 3 places, it can be only 2, that can be selected only one way, because there is exactly 2 zeros and exactly 2 ones. That is what we are calling. Now first place is not 0. If the first place is not 0, first place should be 1 or 2. Now how many places are available for ones? Sorry, we've done this for first place not equal to 0. Now we'll do second case for first place equal to 0. Sorry. Okay. If the first place is 0, now you need only one another place for one another 0. 6C1. Now 2 places are done and 2 places for 2 ones, and the remaining places should be all 2s. That's it. We add this and this plus this minus this, you will get the answer. Is that clear? Next one. Okay, so remaining questions will be discussed by another faculty. So those are a few questions I have selected from paper 1 to discuss with you. Okay, thank you.
So hi everyone, we'll see paper 2 once. Before going for questions, we'll see about the pattern. There are 4 single correct, 4 multi correct and 8 integer type, right? So there are some 3 marks for this, 4 and 4. So in paper 2, relatively integer type questions are easy compared with multi correct or single correct, and at least 2 questions are easy in single correct. This can be lengthy, but in integers around 5 to 6 questions are easy. So we'll see some of them. Look at first one. There is a single correct question. So before solving any papers, you need to go through the paper once, right? If you are attempting maths paper, you can go through all the questions once, so you'll get an idea on which topic you are good at. So this is one of the easy questions. Y is greater than or equal to 1 by x. So can I say it is a rectangle hyperbola? We can take xy is equal to 1. So you'll get one graph in first quadrant and second one in third quadrant. But if you look at first one, x must be greater than 0. Can I say x must be greater than 0 means the graph should not be in third. So consider xy is equal to 1. Now this is equality. We need to go for inequality. So y greater than 1 by x means where y values are greater than 1 by x value. So can I say in this region, this graph will divide the xy coordinate system into two parts. One is this side and another one is this side. So which one we have to consider? Take any random point which is not on the curve. If you take origin or some say 1, 0, then it will give you that we need to consider this area. And what about other two curves? One is 5x minus 4y minus 1 is equal to 0. Take the equality first before going for any equality. It's a straight line. So one is xy is equal to 1 and another one is 5x minus 4y minus 1 is equal to 0. If you observe these two, can you get the point of intersection? Just by looking at it, can I say 1, 1 is satisfying both the conditions? So it will meet at 1, 1. Now if you observe, it is having positive slope. So graph will be like this. Now there is one more line, 4x plus 4y minus 17 is equal to 0. Now get the point of intersection. If you look at these two, what's the point of intersection that will satisfy these two? On adding these two, we get x value will be 2 and y value will be 9 by 4. That means there is one more line, 4x plus 4y minus 17 is equal to 0. So this whole line will be with negative slope. So point of intersection is nothing but 2, 9 by 4. So where will this line intersect xy is equal to 1? We need to solve these two equations. If you look at this, place y is equal to 1 by x. By placing y is equal to 1 by x, we get a quadratic equation, 4x square minus 17x plus 4 is equal to 0. So reciprocal roots. So 1 will be 4 and 1 will be 1 by 4. X value is 4, when you place x value as 4, this will be 1 by 4. So these are the graph. Now look at the inequalities. Xy has to be greater than 1. That means y has to be greater than 1 by x means towards this side. So in this side of the hyperbola. Next, this is second line, which is 5x minus 4y minus 1 has to be greater than 0. So if you observe this line, origin is lying on this side. So substitute origin first. If I take 0, 0 in place of x and y, the inequality is not satisfied, which means origin should not be part of the region. So can I say towards the right side of this line? So this side. And one more line is 4x plus 4y minus 17 is equal to 0. When you place origin, which is not lying on the line, it will be minus 17. Inequality is satisfied. That means you need to consider the region which includes origin. So towards this side. So what's the overall area that you can see? Overall area that we can see is, this is the area up to this. So this green region. So how can I get this value? There are three graphs. One of them is hyperbola, rectangular hyperbola, and two of them are lines. To get required area, what we'll do? We know this point is 1, 1, this point is 2, 9 by 4, and this one. So can you take a vertical line here? Simply can I say, by integrating from 1 to 2, integrate from 1 to 2, first line, which is 5x minus 1 by 4 dx with respect to x-axis. With respect to x-axis, if I integrate from this point to this point, I'll get complete area below to it. And from 2 to 4, from 2 to 4, can I integrate second line? Second line is 4x minus 17 by 4 minus dx. So if you do this, I'll get complete area below to this and complete area below to this one. But what's the area that we don't need? Can I say from 1, 1 to 4, if I integrate hyperbola 1 by x dx, if I subtract this area, can I say the area that is below to this line or below to this curve will be eliminated? So this is the required area. Clear? It's all about drawing the rough diagram. So write this properly, then you'll get the idea. What is the area that we need to find and how to calculate it? Clear? One of the easy questions. And look at this one. If you observe, it is from differential equations. Look at the equation properly. It is nothing but your homogeneous equation. So dy by dx will be x square plus y square minus xy by x square. So what we do? We'll take y is equal to vx. So by placing this, we get v plus x into dv by dx is equal to 1 plus v square minus 2v. So take v to right side, you'll get x into du by dx is equal to v minus 1 whole square. Now separate the variables and integrate. This is your IP level question which is asked in advanced. So if you separate the terms, you can go for integration. You'll get minus 1 by v minus 1 is equal to log x plus c. So replace v is equal to y by x. To get c value, they gave you some information. Y of 1 is equal to 0. Meaning of this is when x is 1, corresponding y value is 0. So place x is equal to 1 and y value is 0. So from this you'll get c value as 1. So replace c is equal to 1. Then we know what to do. We need to find y of e and y of e square. So place x is equal to e, place x is equal to e and find y value. Place x is equal to e square and find y value and place the value. Clear? So it won't take much time to solve this question. Now what about next one? Read the question properly. They gave you some binomial expansion. Yes. 1 plus 2 by 5 x whole power 23 is equal to sigma I is equal to 0 to 23 a x I power I. For every real number, a r be the largest among numbers. What's the meaning of largest? So that they are talking about coefficients, right? Can I say largest coefficient? So what we do to get largest coefficient, we have condition, right? R value must be less than or equal to some n plus 1 into mod b by mod a plus mod b, if you remember this. So R value must be less than or equal to n is 23. In place of mod b, we have to write 2 by 5. So 1 plus 2 by 5 into x. Now question is what to take in place of x. If you observe, they just want coefficient. So take x value as 1. So you get R value less than 24 into 2 by 5 by 1 plus 2 by 5. You simplify this, R value will be less than 48 by 5. 7 by 5 will be cancelled. 6 point something. R is 6 point something. So if R value is 6 point something, can I say term will be 7th term? So 7th term coefficient is going to be numerically greatest. So here only confusion is, do I need to take R value as 7? No. Because I am talking about 7th term coefficient, right? So first term is nothing but starting with A0. Second term is A1. So 7th term will be A6. So R value will be 6. Clear? Now look at next one. Alpha is given. So we have done these type of questions asked in mains level as well. What we do? Observe the angles first. 60, 61, 62 and 63 and so on. Can I say difference is 1? So we have seen when the angles are in AP, then what we do? Multiply and divide with sine 1. I am multiplying and dividing with sine 1. So sine 1 degree upon sine 62, sine 63 and so on up to sine 1 upon sine 118, sine 119. So what we'll do after this? I have done many questions on this one. So express numerator using denominator terms. Can I write this one as 61 minus 60? Yes. Even this one using denominator terms we can write as 63 minus 62 and so on. So what do you get? This 1 by sine 1 will remain as this. Sin a minus b expansion. Sin a minus b is, can I say sin a cos b minus cos a sin b? You'll write. Sin 60, sin 61 and so on. So what's the pattern you get? If you split the term, you'll get sin 61 will be cancelled, you get cot 60. So alpha will be 1 by sin 1 into cot 60. Here what do you get? If you split, sin 60 will be cancelled, you'll get cot 61. So minus cot 61. Observe this pattern. Next, plus here sin a cos b minus cos a sin b. You'll get cot 62 plus cot 62 minus cot 63. Next one is going to be cot 64 minus cot 65 and so on. So even numbers are getting positive sign. At then what do you get? Cot 119. Even numbers are getting positive sign and odd numbers are getting negative sign. Cot 119. So how can I simplify this? I don't know the values of cot 61 or cot 62 and so on, right? There will be some clue here. How can you rewrite this? Cot 60 minus cot 61, cot 62, cot 63, up to 90. If you assume, it will be cot 90 minus cot 88. Now, after this, what do you get? Cot 92 minus cot 91 and so on. Cot 118 minus cot 119. So, what we can do? Can we replace 119 using 180? I can rewrite this statement as 180 minus 61. So 1 by sin 1, this will remain same. So cot 60 minus cot 61. These terms will remain same. Here in place of this, I can write cot 180 minus 61. Same values. Cot 180 minus theta is minus cot theta. So there is a minus sign already. Can I say it will become plus cot 61? Okay. Next. Here what do you get? I can write this 180 minus 62. So 180 minus cot 180 minus theta is minus cot theta. You'll get minus cot 62. Now, if you observe from the beginning, can I say minus cot 61 and plus cot 61 will be cancelled? In the next one, first term is going to be plus cot 62. That will be cancelled. Can I say in the next case this will be cancelled? So what are the terms that will remain? Alpha value will be nothing but 1 by sin 1. Cot 60 will remain as it is. And with cot 90. We know cot 90 is anyway 0. And cot 60 value is 1 by root 3. So alpha is equal to 1 by root 3 sin 1. So they are asking, we can write as cosecant 1, cosecant 1 by alpha, that is root 3. Square of cosecant 1 by alpha, which is 3. That is the answer. Cosecant 1 by alpha whole square. Clear? Now, how will you solve this one? If you remember this, it will be discussed whenever definite integration is there. This part will be discussed and stressed. 1 by 2 to 2. It looks like interval is from 1 by a to a. Whenever you see an interval from 1 by a to a, the only thought that you need to get is we have to split the interval. How to split the interval? Can I split the interval from 1 by 2 to 1? And 1 to 2. So what happens if you do this way? Every time you see 1 by a to a, this is one idea that will be helpful for most of the questions and asked in mains level. So what we do? Keep any one of the integral as it is. That means I want to keep 1 by 2 or say this one, first integral as it is. I'll go for next one. So what we'll do here? Replace x with 1 by t. The reason why we are replacing x with 1 by t is, if you replace it, the intervals will change. They will become 1 by 2 and 1. So by replacing x with 1 by t, differentiate both sides, we'll get dx is equal to minus 1 by t square into dt. So rewrite the given question. I can write, when x value is 1, t value is going to be 1. When x value is 2, t value is going to be 1 by 2. This is what you get. First integral, let us say this is some I. First integral will remain as this. Next one, in place of x, I am writing 1 by t. Now in place of dx, I can write minus 1 by t square into dt. In place of x, I need to write 1 by t. So I'll get 1 by t whole square minus 3 into 1 by t plus 2. We are not doing anything, just replacing x value in terms of t. That's it. Clear? So alpha will be nothing but first integral minus integral 1 to 1 by 2 tan inverse 1 by t and dt by t square upon, here if you take LCM, what do you get? You'll get 2 minus 3t plus 2t square by t square. Can I say this will be cancelled again? So how can you rewrite tan inverse 1 by x? Tan inverse 1 by x can be written as cot inverse x. If I interchange these two, if you replace upper limit to lower limit, if you interchange these two, can I say you'll get extra minus sign? Tan inverse x can be written as cot inverse. There is a condition, remember, only when x value is positive, then only you can do this. So 2t square minus 3t plus 2. And in case of definite integration, can I say variable is dummy? So you can replace t value with x. So it will be cot inverse x by 2t square minus 3t plus 2. I am replacing t value in terms of x. So your first integral is nothing but integral 1 by 2 to 1 tan inverse x dx upon 2x square minus 3x plus 2. Now since the integral limits are same, denominator is all the same, simply add these two, these two. We'll get alpha is equal to integral 1 by 2 to 1 tan inverse plus cot inverse is pi by 2, a quadratic expression. You know how to integrate a quadratic expression, right? So one of the familiar questions which is asked in mains as well. So find this integration, place alpha value back in this one, we'll get the answer. So see, we have, if you observe properly, out of 8 integers, we can solve at least 5 to 6 integers without any difficulty. There is one more question based on complex numbers. Omega is a cube root of unity and some alpha is defined. It is nothing but argument of minus sigma n is equal to 1 to some 2025 minus omega whole power n. Again, this is your mains level question. It's not an advanced type. So when you place n value as 1, 2, 3 and so on, this is what you get up to minus omega whole power 2025. So by looking at this, one way is you can say this is in GP, can we apply sum of n terms of GP? Yes, you can do. You'll get the answer. Any better way? Instead of applying GP, observe this carefully. If I write first 6 terms or 7 terms, whatever it is, and so on. Observe this one. Can I say in place of omega cube I can write 1, in place of omega power 5 I can write omega square. Can I say sum of these 3 values is 0, 1 plus omega square, take minus n common. Now observe these even powers, omega square, omega power 4 and omega power 6. So again I can say sum of these 3 will be 0, we'll get 1 plus omega square. So if you are writing this way, every 6 terms sum is going to be 0. Every 6 terms sum is going to be 0. So that way you can solve this question in easy way. So overall what I can say is anything around 40 to 50 can be scored if you are prepared only for mains level. You don't need advanced pattern or advanced level questions just to crack this exam. So this is one of the easy marks in maths paper 2. So relatively paper 2 is easy compared with paper 1. Expect cutoff to be very high. So I'm expecting anything around 180 is required to get 5k below. Around 5k if you want to get 180 plus is required, not 180. Maths paper is similar to your mains level, it's not advanced level. There are 3 or 4 questions hardly that are decently given. But even probability question is direct if you understand Bayes theorem. So it's all about choosing the right questions. If you get stuck in tough questions, it's not going to be helpful, right? Initially if you observe 1 or 2 questions are little tricky, which may consume more time, but integer questions are direct questions. If you have practiced last 3 year, 4 year mains papers, that is sufficient to get 30-40 marks easily in paper 2. So that's it from this paper. Hope they will increase the level of advanced paper from next year. If this pattern continues, then cutoffs will be very high. Thank you.